there is always going to be that sense of mystery. I think we need to recognize that there are certain unknowables, just in terms of our empirical ability to do any kind of research on them. And so that mystery and awe is going to be there. But that mystery and awe does not necessarily validate the explanation from a theist perspective.
If we have such a narrow view of nature that we want to explain everything deterministically by reference to underlying physics and chemistry, and that there's nothing else except things that are going on at that level, ultimately, then I think we get a very impoverished view of reality, which makes it impossible to pursue the kind of project that Saleem is pursuing.
Hello, welcome along to today's show. If you're new here on the YouTube channel, do make sure to give us a like and subscribe to us for more of these fascinating conversations. You can get, of course, our regular podcast and our newsletter by clicking the links with today's show. Well, today we're asking, where does order in nature and the cosmos come from? It's a big question, isn't it? And one person seeking to answer it is Professor Saleem Ali, Chair of the Department of Geography and Spatial Sciences at the University of Delaware. His book, Earthly Order: How Natural Laws Define Human Life, was recently published by Oxford University Press and explores the laws that seem to govern the order and pattern that appears in everything from nature and the universe to economics, society and even religion. Well, in conversation with Saleem today is Dr Stephen Meyer of the Discovery Institute, whose most recent book, The Return of the God Hypothesis, detailed three key aspects of our understanding of life and the universe that he believes point towards a designer behind the order in nature, God. And today we'll find out where they agree and perhaps disagree on the way nature exhibits patterns of order, and whether nature can explain itself, or should we be seeking an explanation beyond nature. Saleem and Stephen, welcome along to the show.
Thank you, Justin.
Thank you, Justin and Saleem.
It's great to have you both join me. Saleem, a newcomer to the show, great to have you on. Fascinating book, and we'll only be able to scratch the surface inevitably on today's show because it covers such a huge range of subjects. But tell us a little bit of your own background and what brought you to the point of wanting to write this particular book.
Yes, so, the journey for this book, as I state in the introduction, goes back to my PhD days at MIT, where I had an opportunity to interact with the late Stephen Jay Gould, whom many of your listeners would probably know as a very distinguished popularizer of science. And I was working at the time on a project around public intellectuals, and I got a chance to interact with him. And I was really taken by his view of, how he considered this kind of relationship actually between science and religion, where he talks about non-overlapping magisteria. And so that's when I started to think about writing a book on order and considering the functionality of order. I'm trained as an environmental planner. My PhD is in planning, and so I'm very solutions oriented. I try to try to find a path towards what can we do towards a more sustainable future. So the book was written with that view, not just to look at the philosophical underpinnings, but to see how we can use concepts of order to have a more sustainable trajectory for managing our planet and indeed human societies. And so that's how I started to work on it. But it wasn't until almost 2 decades later that I actually was able to find the time and I would say the intellectual maturity to write it, because it did require a lot of reading in order to do justice to the topic.
Yeah, and as I say, it does cover a great wealth of information and ground. It starts really, I suppose, at the fundamental point of sort of order in the basic reality of nature, the cosmos, then kind of takes you deeper into chemistry and biology, and then of course into sort of more the world and culture and society and so on. Do you see this as all on the same spectrum? Many people want to divide these things up into, very separate disciplines. You obviously see that there's a sort of something that brings them all together.
Well, that was another reason for writing this book, is that I wanted to make sure we approach the topic with nuance and recognize that we can be very deterministic around order. It's very captivating to use the concept of order in a way which can lead us astray also. So there is this constant dialectic between order and disorder in the universe, which makes reality what it is. And I'm also very conscious about considering order in both of its Greek roots of the term. One is cosmos, which is the term we think about for natural order, but the other classical term is taxis, which is artificial order, constructed order. Both have meaning and opportunity for us to consider a more sustainable society. And in fact, when we think about religion, in many ways, the concept of taxis provides us some functionality which is still important, even if we don't consider it in its literalist terms. So that's how I've tried to approach the concept of order in the book as well.
And I suppose at its centre, do you think that the order that seems to permeate, as it were, from cosmos to the conversation we're having, that's something that is imposed by us? We kind of see order because we're meaning-seeking, pattern-seeking creatures, or do you think there is embedded within material reality an order that is just there, and does it need some kind of explanation?
Yes, I think there's both. There is no doubt some fundamental order. The laws of nature, if we were to define them in those terms, when it comes to the functionality of systems, whether it is physical systems or biological systems, and that's the kind of order that comes through in mathematical equations and so on. But there is also constructed order, which we as humans construct to make sense of the world and to also organize society. And there can be a connection between the two. Sometimes it is opportune to try and have constructed systems which emulate natural order. That is where, if you're an ecological planner, you want to do what we call biomimicry, where you try to mimic natural systems in terms of how you design cities. But at the same time, there can be a very prejudicial aspect of constructed order, which we have to be cautious of. That's how stereotypes arise, where we start to see patterns where there may not be patterns, right? That's how societies get into the trap of becoming prejudicial, because they try to see that, if this is how certain group of people behave, there is therefore this pattern of behavior, and hence we try to marginalize those societies. So in earthly order, I'm very conscious of both. And that's why, the book is divided into these three parts: natural order, social and economic order, and political order, because I want to differentiate where those kinds of fault lines lie.
Yeah, thank you. Anyway, I'm looking forward to getting into some of the examples of that. I suppose in my mind, I've thought of us kind of staying near the beginning of the book with the sort of order in the cosmos and nature, with Stephen joining us for this conversation, which is obviously his area of expertise. But I know, Stephen, that you're just as fascinated, having read Saleem's book, by the way he sees order in all these other aspects of life. What's been your thoughts on this book?
Well, absolutely. My background's in physics and earth science, but then in the philosophy of science and history and philosophy of science. So an interdisciplinary book like Saleem's is really fascinating. The scope of it is wonderful, and he touches on this concept of order at the lowest level, if you will, in the reductive hierarchy of physics, also in chemistry, in biology, but then also looking at the way in which order emerges in sociological arrangements, in economics, and in human society. So it's very, very broad and comprehensive in scope. I enjoyed it very much. I love the comment he was making at the end about the difference between the order that is indeed intrinsic in nature and the order that we might, or the patterns that we might perceive that may match the patterns that are in nature or may not. And I think that in essence, science is about trying to get the patterns that we construct in our minds to match the patterns that exist in the world, so that we're accurately reflecting in our theories what's actually out there. And I think one of the really interesting things about the scientific revolution was the confidence that this was both possible, and also we had to be careful that you had this in the scientific revolution, there's notions of testing that were, I think, reflective in some ways of theological assumptions about the fallenness of man and the fallenness of our intellect, that we could easily jump to conclusions. We were subject to fights of fancy, but
Yeah.
that we were also capable of understanding that order, that it was intelligible to us because the gift of rationality that had been endowed by our Creator in us was also the source of the patterns and the order and the design in nature. So there was a principle of correspondence. So if we were careful to avoid indulging prejudice and testing our ideas against how nature actually works, it was possible to discern, as Kepler put it, to think God's thoughts after him, to understand what the order that God had placed in the natural world. And so that assumption, that it was a twofold assumption, one of the intelligibility of nature, but also an awareness of the fallibility of human reason, and that gave rise to rigorous methods of testing, but also a confidence and a motivation to discover and to study the natural world. And that was part of the scientific revolution. And I think interestingly, it does have a theological premise in both cases.
Yes. Yeah, that's an interesting place to start. I mean, remind us of your book, The Return of the God Hypothesis. I think it was almost 2 years ago, probably, I had you on with Brian Keating to talk about it. But what are maybe some of the overlaps in terms of the themes in your book with Saleem's own work here?
Well, it might be helpful just with my background. I did my PhD in origin of life biology within the Department of Philosophy of Science in Cambridge, and so I've been very interested in these issues of emergent versus extrinsic sources of a particular kind of order, what the Greeks called taxis, the order of specified arrangement that's necessary to function, rather than just a simple pattern. Because what you have in biology is not just a simple pattern like Mandelbrot set or a tornado or a swirling vortex in the bottom of a bathtub. You have rather something that is characterized by a specificity of arrangement of parts in order to perform an overall function. And that kind of order requires, as an antecedent, information. So there's an informational order or an informational source of that kind of order that's critical to explaining the origin of the first life. And so my PhD was in that on origin of life biology. Like Saleem, it took me almost 2 decades to write the book that I first started thinking about during my PhD years. It was Signature in the Cell. I finished my PhD in 1990, and Signature in the Cell came out in 2009, so it was almost 2 decades. So same story there. And so in that book, I argued that the informational properties of the cell, the digital code in the DNA molecule, the information storage, transmission, and processing system that you find in living cells, the things like automated error correction and control systems, all these features of living systems are not reducible to the underlying order of physics and chemistry. They are consistent with the underlying principles of physics and chemistry, the laws of physics and chemistry, but the laws of physics and the laws of chemistry at a lower level leave unspecified a vast ensemble of possible arrangements of matter, where in the living state is only one of, it occupies a tiny little portion of that set of possibilities. So that's been a huge question for origin of life researchers. How do you get from the chemistry of the prebiotic world, which is characterized by chemical reactions and chemical laws and physical laws that we can easily characterize, but don't specify that living state? How do you get from chemistry to code, if you will? And so my first book argued that the informational properties of living systems, the digital code in DNA in particular, but the whole information processing system, manifest features that are characteristic of one and only one type of cause in our experience, and that type of cause is agency or intelligence. There's a famous early scientist, information theorist, who was applying the concepts of information theory to molecular biologist Henry Quasler. He said that the creation of new information is habitually associated with conscious activity. And I had various ways of testing that counterfactually, but ended up affirming that basic principle was correct, and therefore we could infer from those informational properties of living systems back to the action of a designing mind of some kind. In the book, I didn't attempt to specify the intelligence. Some of my readers subsequent to that began to query me, well, who do you think the designer is? I have never been favorable to the space alien designer hypothesis, and so I came clean in my recent book and brought in evidence from cosmology and physics, in particular the evidence of the fine-tuning that's been present from the very beginning of the universe, and the evidence that the universe, as best we can tell, had a beginning, and suggested that those three lines of evidence, the evidence we have of design and biology from the digital code, the software of the cell, the fine-tuning in physics, and the cosmological singularity are best explained at a metaphysical level by theism as opposed to other competing worldviews, such as, for example, materialism, pantheism, deism, etc. So that's sort of my intellectual program, but very happy to intersect with what Saleem is doing because it raises a lot of other issues that I've thought about. For example, what is a law of nature? It's something philosophers of science think about. There's basically three distinct views of that, and maybe we can talk about some of them.
Okay, well, yeah, we could get into that. I mean, perhaps a good moment then to kind of lay cards on the table here, Saleem, because when I saw your book, I did think of Stephen because order, complexity, it's obviously in the wheelhouse of what's sometimes called the intelligent design movement. Though, I mean, the one reference I did find in the book to intelligent design wasn't necessarily particularly, praising the movement. If you don't mind me reading it back to you, we'll just see where, what you think of this. In a chapter called Seduction of Structure in Nature, you write, emergent natural order of molecular transition from chemistry to biology rests on the key success of chemical upscaling, and herein lies the major contestation between proponents of nature's bottom-up order, proposed by Darwinists, and the top-down order, proposed by proponents of intelligent design. The latter group, championed by controversial think tanks such as the Discovery Institute, often end their argument with the molecular improbability of chemical upscaling. And you go on to say the intelligent design proponents try to differentiate themselves from creationists by noting they're not presuming theological origin, but rather considering a process of elimination approach to scientifically plausible alternatives. So where do you stand then with someone like Stephen, who obviously is saying, look, this order seems to be speaking of something beyond itself, agency, intelligence, and that kind of thing?
Yeah, I mean, I think the issue I have in general with having patterns provide some kind of deterministic causality applies not just to intelligent design, but it applies to actually some mainstream physicists who would claim, string theory or other kinds of more, conjectured approaches to suggesting that you can have internally consistent mathematics to show the same. And so but I do want to show humility to say that I'm not kind of dismissing them. I'm just saying that we should be just cautious about what you can elicit from them. So, for example, with reference to fine-tuning, which you mentioned, and that is one of the core arguments in Steve's book around the return of the God hypothesis is the fine-tuning. Indeed, Richard Dawkins, I think in one of his conversations with you, admitted that if there was an argument for God, that's probably the most plausible one. But if you actually go into the detail around fine-tuning, and the reality will come out as well, you could have an alternative kind of universe which may have emerged with different kinds of life forms if the fine-tuning was different, right? So, and you don't even have to go the multiverse approach, which is even more conjectured, and it is going into the same realm then of the kind of string theory and so on, and it's not empirically determined. I think what my concern is that you can get into a situation of infinite regress problems if you really get hung up on that, which is the infinite regress, meaning you're ultimately then who created the creator and so on and so forth. And then similarly, the other approach is with the simulation hypothesis that, okay, if it is this fine tuning is the way it is, then are we living in a simulation, which is the Nick Bostrom type of approach. And I think it's very enticing philosophically, but as a planner, I don't find that also very useful, because it's ultimately like, if you're and he admits it too. He was like, ultimately then the simulation goes back to the same kind of issue. So what I think is that we should show some humility, both in terms of the natural scientists as well as the deists, in saying that right now we really do not know what is the ultimate aspect, but I think it's very plausible for us to consider that if there is this kind of an approach of saying that the complexity could not have emerged without some kind of higher planning, then, and if that provides meaning for people to make sense of the world, I don't have a problem with it. I believe in what Winston Churchill said. He basically said, whether you believe or not, it is a wicked thing to take away people's hope. And I go by that. I have no problem with that. I don't have a personal hubris around like this is right and that's wrong. So,
but I know that you, Steve, have said frequently, look, I don't believe this because it gives me some sort of nice feeling inside and hope. It's because you think that's where the evidence is pointing from the natural world, right?
Sure, and I also read the passage that you quoted from Saleem's book, but he also cited there to a favorable book review of one of my books. So I didn't get my feelings hurt. I thought it was a fair comment. And beyond that, I loved the way he distinguished these two concepts of the top-down versus bottom-up sources of order, because this is an ancient discussion. And there have been many people who've tried to stigmatize it and to say, well, it's not a legitimate discussion. We should just stick with the standard neo-Darwinistic explanation for everything, or chemical evolutionary explanation for the origin of life. And there's nothing here to discuss. But I think that the kind of order that we find in life, and I think this is just a distinction that I'd like to introduce into the conversation a bit more, is different than the kind that we find in strict physics. I wrote on the page, I won't put it in front of the camera, but you can your audience can easily imagine. If you have a crystal of salt, you have a repetitive sort of periodic order, NaCl, NaCl, NaCl. You can write most of the fundamental equations of physics, the laws of physics, onto a single sheet. Maxwell's equations and Einstein's version of gravitation, Newton's earlier version of gravitation. In electronics, E equals IR. It's an incredibly useful law, but it's that simple to represent this repetitive pattern that we see in the relationship between voltage and current and resistance. But take that example as a law of nature. That law does not determine how we arrange the resistors, capacitors, and transistors on a circuit board to produce a particular function. That arrangement of parts is what Saleem termed taxis from the ancient Greeks. It's an arrangement type of order, not a simple pattern. It's not, like a snowflake or a crystal of salt. And so there are these self-organizational scenarios in origin of life research, and Saleem referred to some of them, the work of Stuart Kauffman, for example, or Jeremy England, or Manfred Eigen, that do a very good job of explaining well what doesn't need to be explained when we're talking about the origin of life. They explain the origin of order in this sense of simple pattern or repetitive structure that's reducible to a differential equation or an algorithm, but the kind of order we have in a gene sequence is much more like software, in the sense that it's not compressible to a simple algorithm. And that type of and there's a name for that in the information sciences. It's called specified information or functional information, or going back to a coinage from Leslie Orgel, one of the great origin of life researchers, it's specified complexity. And it's qualitatively different from mere randomness or mere complexity, sort of gibberish. You could think of the monkey at the typewriter typing out a bunch of characters. And it's also qualitatively different from order in the sense of what you find in a crystal or in a vortex, or the kind of order you get when you pump energy through a system and move it far from equilibrium, and you get some simple patterns emerging. So
when I think of that, if I could give an example.
Yeah.
When I spoke to Jeremy England, and he was in conversation with Paul Davies on Origins of Life and that kind of thing, it was interesting that yes, what I think Jeremy England identifies are, in a sense, the way in which there is a kind of structure within nature that allows potentially energy to be used at its most efficient when certain things come into play. So I might liken it, as a pure layperson here, to sort of when I have a bowl of sand or something with some large pebbles buried in it. If I just shake it, I know that the large objects will move to the top, because that's just the way that the natural laws kind of. Now, at one level, you can kind of say, well, that's just a natural process, and it's not being directed by some agency. But what you're describing, Stephen, sounds like, well, you've got those kinds of processes that kind of, create a certain form of order, that don't need, in a sense, to be explained by something beyond themselves, but that at the next level, which you're talking about, the code level, you move well beyond that. Is that what I'm hearing?
Right, exactly. And in characterizing the effect, there's some clear qualitative differences between order that's reducible to algorithm or differential equations, and the order that's not compressible in that sense. It's informational, like code. Paul Davies is in a book he did on the origin of life, was very, very clear in characterizing the effect of life, that it in fact, it's informational, it's specified complexity. Here is a simple example. I used to use with students, with just the difference between a mantra, a repetitive phrase, and a message, where the characters are aperiodic, non-repeating, and yet they are specified sequentially in accord with some independent symbol convention to convey meaning or to perform a communication function. And this was the great breakthrough of Francis Crick's, 1958, 5 years after he and Watson had elucidated the structure of DNA, and at the time anticipated that it might have something to do with storing instructions. But in 1958, Crick formulated the sequence hypothesis and suggested that the nucleotide bases, the subunits that run along the interior of the famed double helix, are functioning like alphabetic characters in a written language, or we would say today like the zeros and ones in a section of machine code, which is to say the function they perform is not in virtue of their physical chemical properties, of the underlying laws that pertain thereto, but rather the function they perform is a consequence of their specific arrangement in accord with an independent symbol convention, later discovered and now known as the genetic code. Now, that kind of order in the information sciences is so different from what we typically think of as pattern order that it's no longer called order. It has its own name. It's usually called information, and an additional modifier, because information can just mean arrangement of characters that are highly improbable, but a specified arrangement of highly improbable characters, sometimes now called specified complexity or information. And the argument that I make in my book is that that particular kind of order requires top-down causation, and I say requires because in our uniform and repeated experience, the basis of all scientific reasoning, we know of only one cause that produces that kind of order, whether we're talking about the digital code in software or a section of text in an English paragraph, or the information that's embedded in a radio signal or transmitting now across the internet between the three of us. Information that has that character of being specified by an independent convention is the provenance. It's the provenance of mind. It comes from intelligence. So it's appropriate based on our experience to invoke a top-down model of causation rather than a bottom-up.
Thoughts on that, Saleem?
Yes, well, I think there's some contestation of that kind of view if you look at some of the work of, for example, Frances Arnold, who won the Nobel Prize in Chemistry recently, and she works on finding ways to design enzymes that are going to be functional. And I talk about her Nobel Prize speech, in which she talks about this massive library that you have and how you arrange the books in a library, whether it is by alphabetical order or by subject area, and that in natural systems there's a lot of redundancy and detritus, and the information systems that Steve is referring to, they actually are not as neat as sometimes when we see the finished product come out to be. So I think what Steve is saying is really important in terms of one of the ways in which we need to be looking at these issues on the origins of life. But some of the research suggests that there's actually, even in terms of informational processing and order emergence there, that it's a much more messy process than what might be implied if it was completely top-down designed. And in fact, the concept of entropy itself is defined in terms of information, in many of the ways in which physicists approach it, certainly. So I think we need to be a little bit more careful. I think it's still an important area for us to keep exploring, but I would suggest that it's a little bit messier than what Steve may be implying.
We'll come back to you, Steve, for a response to that.
Yeah. Just
because we're going to go to our first break, and I'd be fascinated as well to dig into some of the other things you were suggesting we might touch on, what a law of nature actually is, and perhaps different definitions that have been given for it, and so on. But we're having, I think, what is a great and wide-ranging, hopefully, conversation on order in nature and the cosmos. My guests today on Unbelievable are Professor Saleem Ali and Dr Stephen Meyer, and we'll be back in just a moment. 2/3 of people believe that science and religion are incompatible, according to a recent UK survey. Many of the key atheist voices in our culture have used science as a battering ram against Christian belief. But there's a different story to be told about science and faith, and few people better to tell it than John Lennox, Emeritus Professor of Mathematics and Philosophy of Science at the University of Oxford. I'm Justin Briley, and in this new online course from Premier Unbelievable on science, faith and the evidence for God, you're invited to learn from one of the most celebrated Christian thinkers of our time as I open up the conversations I've hosted between John Lennox and atheist thinker Michael Roos and secular talk show host Dave Rubin. Across 9 modules, you'll discover how Christianity grounds the evidence for God, why it led to the rise of modern science, what response we can give to the question of evil, whether miracles are anti-scientific, and why atheism and science can't account for human value or the biggest questions our culture is asking. As well as my guide to these top-flight conversations, the course includes supplementary video material from lectures delivered by John Lennox on God, faith and science, along with questions and assignments to help you ground the various learning points in each module. You can take the course at your own speed and in your own time. Enroll now at the link with this video and learn how to make sense of science, Christianity and secular culture. Welcome back. I'm really looking forward to the rest of this conversation today because it's always fun to be joined by Dr. Stephen Meyer of the Discovery Institute. His most recent book was The Return of the God Hypothesis. He came on a couple of years ago on the show to talk about that. But coming on this time to talk with Professor Saleem Ali, whose new book Earthly Order, How Natural Laws Define Human Life, was recently published by Oxford University Press. And as we've been hearing, Stephen, Saleem, I think there's a lot of overlap with where you are and your approach, but some concerns as well that sometimes the nature of these things is messier than it's sometimes presented. He fears by some folk in the intelligent design community that actually, these top-down processes aren't always as obvious as perhaps. But what did you want to say in response to that briefly?
Well, 2 things. One, by way of defending our position, and then one by way of raising a challenge for the self-organizational approach. We won't settle the issue about the origin of new proteins or new protein folds in this 25 minutes. So I'll try to keep it briefly, but brief comments. But we're very aware of the complexity of this issue, and fundamentally, what we think is going on is that that when we're looking at protein design or site-directed mutagenesis or some of these processes where you can explore how much variability is allowable in a stable protein structure called a fold, that you can present that the picture of biological reality with something called a fitness landscape, where the peak represents a stable fold that's function ready or function capable. And what I think the experimental research has shown is that, yes, you can modify those proteins and you can get different, slightly different functions within the structure of a stable fold. And then the valleys represent where you've dropped off into a non-functional abyss. And the challenge in evolutionary biology and explaining these very important structures, because biological reality is denominated in proteins. They're the fundamental structures that you have to perform any function. So the question is, how do you get a new protein fold capable of new function from an existing protein fold? How do you get from one peak to another without falling into one of these functionless abysses, separating the two? And some of the work that Saleem has cited does a good job of explaining how the proteins can be modified around those peaks to perform sometimes new functions, but within the structure of that protein fold. That's what you can think of as molecular modification. It's modest, but it's real. The real problem is in the molecular, at the level of innovation, getting a fundamentally new fold. And work that my colleague Douglas Axe has done at Cambridge University, and then some work that was done at the Weizmann Institute by a molecular biologist there, a protein scientist named Dan Tofik, suggests that these stable structures are extremely rare in what's called sequence space. Of all the possible ways of arranging the amino acid subunits, there are very, very few that form stable protein or function-ready folds, but they're also isolated. It's hard to get from one peak to another. Dan Tofik's work showed that if you start with a stable protein fold and you induce between 3 and 15 mutations, it's enough to cause that stable structure to lose thermodynamic stability and therefore the ability to perform functions. So the work that's done, we think, shows, yes, you can modify proteins to get sometimes new functions within those stable structures, but getting the fundamentally new structures that constitutes real biological innovation is what lies beyond the bottom-up Darwinian process, and that's where we would see the need for new information that would need to come extrinsically into the system, i.e. that would be evidence of design. So that's our view. We probably won't sort all this out. It's too technical in a conversation like this, but I take the point. There's obviously nuance and subtlety in this. On the flip side of it, just real briefly, there's a lot of literature on so-called self-organizational scenarios, like Stuart Kauffman and Saleem cited some of those guys, and Manfred Eigen. And I have quite a lot on this in my first book, Signature in the Cell. And what I show is that these self-organizational models, do a good job of explaining the origin of order, but not specified complexity, as we were making that distinction in the last segment. But also, invariably, even to the extent they're successful, they end up presupposing prior unexplained sources of information. So in Manfred Eigen's hypercycles, he starts with a whole bunch of information in RNA molecules, as well as with 40 separate enzymes. In Stuart Kauffman's work, he has a origin of order scenario, but he starts he acknowledges that there must be a high degree of specificity in the arrangement of low specificity parts in a kind of, he calls it a chemical minestrone, and he can get straight from there, he claims, to metabolism. But to get the complexity of the metabolic system, he's got to start with a highly specific arrangement of these low-level parts. So he just begs the question as to the origin of that information at the lower molecular level. So information turns out, in our view, to be something that is fundamental, non-reducible, but also it's often presupposed even in those allegedly successful self-organizational models. They presuppose unexplained, prior unexplained information that's kind of gets shunted out of view, whether it's Eigen's RNA and enzymes or the protein molecules and molecular organization that Kauffman presupposes.
Yeah. Saleem?
Yeah, I can quickly respond to that. Yes, no, I think that complexity of research approach is very appropriate. However, again, the origin of life biochemistry is a highly contested space still. And what we find is even within the sort of conventional scientific approach, we have had a lot of errors that were made. Like, we had the original sort of chemical soup approach that people thought that you get all these, different kinds of basic elements together, you pass an electric charge and you get amino acids. And we found that that's not necessarily the way things happened. But then you've got the RNA world approach, and then actually in my next book, which is coming out, which is about the metal aluminium or aluminum, depending on which side of the Atlantic you are. Yeah. And the other side of the story there is, what was the role of metals in the emergence of life? And there's a whole group of origin of life researchers who puzzle over that, because aluminum is fascinating. It's the most abundant metal in the Earth's crust, but it has been rejected by life. Why was it that aluminum, which is so abundant everywhere, was rejected by life? And there are bioenergetic reasons for why that happened, And so I think what Steve is getting at is that there is a lot that is unexplained. I totally agree with him, but there is a very vibrant area of research that's going on in this regard. And it is interestingly revisiting some of the kinds of things that were previously anathema, like vitalism. The concept of vitalism in science was really a word you didn't want to use if you were a mainstream scientist. But you now have people at Caltech like Rob Phillips who are using the term molecular vitalism in public lectures, because there is a recognition that there is this, we don't understand the energy dynamics that are occurring in certain ways, and vitalism can describe it. It's not in the same sense of vitalism that the traditional sense, but it is one which we can play around with. So what I would say is that there's a lot which can be further investigated through conventional means on
this. Mm-hmm. But it is in the end the kind of direction of where the kind of those folk, mentioned a lot of names there. Are they all fundamentally agreed that it's still a self-organizational principle, that there's no external sort of information coming in? It's still a bottom-up approach.
It is, and that's what I'm trying to say, is that there is this vibrant area of research which can explain it, is attempting to explain it through the bottom-up area. I don't know if they'll end up in another dead end, but it's just to say that the case hasn't been rested by them either, and they're looking at these other avenues beyond the kind of fitness landscape proteins, the approach that Steve was talking about.
Well, as Steve said, we're not going to settle this in today's show, though I find it a fascinating area.
It's really fascinating, and I love these new approaches in origin of life and the simulation experiments that are done to test them. I think that they're telling us something, though, about the importance of as Thomas Nagel put it, mind and cosmos, that in addition to physical order, there is a reality of consciousness and mind, and we can see hints of that in life. And you see this actually in the origin of life simulation experiments that are conducted to test these new models. Because the logic of a simulation experiment is that we're going to try to reconstruct conditions that we think might have been present on the early Earth, and then see what happens in the present. So our knowledge of those cause and effect processes that we see ensuing will help us reconstruct what might have caused life to arise on planet Earth. And there's something that's emerged invariably from these experiments, and that is to get the chemistry to move in a life-relevant direction. The chemist repeatedly has to impose constraints on what the chemical reactions would naturally do. So if you got reagent A and reagent B and they combine, well, they'll make AB, but they'll make a whole slew of versions of AB, and the chemist has to fish the AB version 3 out of that gamesh of possibilities. And what the chemist is doing at that point is excluding some options, electing another, and then moving in a kind of a reaction called relay synthesis. Then oftentimes what they'll do is they'll just buy the reagent that they want off the shelf that's already been purified by an intelligent agent. And so at each step of the way, there's an impartation of information. If you exclude some options and elect others, you're imparting information into your simulation, and that information is invariably coming from the experimenter. And so I think I think nature is actually telling us something here. These simulations are invariably require the imposition of intelligence to proceed in a life relevant direction, and so you have to ask, well, what are they simulating? And if this is something that is consistently arises in all simulation experiments, maybe they are pointing to a top-down approach, a need for a top-down explanation in explaining the origin of life, because all of the simulations require top-down imposition of intelligence and information into the systems.
I mean, maybe we'll leave that one there for the moment. There was another kind of fascinating thing you hinted at earlier, Stephen, which was the idea of the laws of nature themselves,
we can
which
shift,
kind of is taking us right back from the molecular biological side
to the bigger picture, which is more what Saleem addresses.
Yeah. It is. And Saleem, where do you go with this in the book? Because, as I say, this is sort of where the book begins. It looks at that big picture of why there is, this simple order that seems, that seems to run through the whole of nature. You talk about then how that is expressed in various aspects of your the chemistry and that sort of thing. There are certain types of patterns and shapes that are repeated and which seem to enable things to develop and so on. I mean, what? But yeah, if you just go back to the laws of nature themselves, do you conceive of that as being this kind of cosmos type order, this kind of order that is there within nature, and it is something we've obviously haven't imposed, but appears to be ready made, as it were, for us?
Yes, I mean, I think there is clearly some measure of agreement, consensus across the board that there is that cosmos type order, and that is true in the natural science community more broadly, and among deists and theists as well. Whether we look at the fine structure constant, we look at Sir Martin Rees's book on 6 numbers, which define the sort of the Goldilocks zone that we have in terms of existence. So I think that is fairly well established. The question that I am more interested in the book is what is our understanding of that have to do with our trajectory towards being a sustainable society and in terms of planetary sustainability, which is why the book is titled Earthly Order, because I am very focused on environmental learning and making sure people understand these fundamental constraints that are there. And I look at it from the point of view of those constraints. So as an environmental planner, I talk about planetary boundaries, which is sort of a literature that has emerged around how humans need to consider certain boundaries in terms of our impact on the planet and so on. So that's my goal. And that's where the book is written in terms of providing that foundational knowledge for society at large. And that's why I'm donating all the royalties for science literacy, because I feel, this is really meant for making sure people have, we talk about so many different kinds of literacy requirements. People need to be culturally literate and diversity literate and so on. I think we need to be environmentally literate around the basic, fundamentals of these kinds of constraints we operate under. So that's how I approach the laws of nature. But I'm very conscious of also saying that human beings now have the agency to actually trump some of those laws in certain ways in the short term. But in the long term, they will come back to haunt us, because there are only limits to which, if we push them above that, equilibrium, whether it's we talk about tipping points. I have a discussion of tipping points in the book. And humans have the ability to push the envelope, but then eventually we have to deal with those constraints down the road.
Yeah. Stephen?
Well, one of the things I loved about Saleem's book was his description of order at different levels in a kind of a hierarchy, where you can start with these very broad and extensive laws of nature and physics that apply to all of the universe everywhere, right down to the quarks and the fundamental particles and energy. And then you have chemical laws that apply to chemistry, where you've got certain chemical compounds and they react in specific ways with others. So that's a slightly more constrained system but still manifesting law-like regularity. Then you have these systems. You have regularities in biology, but they ensue, once you get all the parts right, then you get things like mitosis and meiosis and DNA replication. So those are kinds of regularities, but they only occur in a biological system. And then at still higher levels, you have laws that are present in, or patterns of order that are present in human society and economics and things that pertain to our interaction with the environment. So there's a kind of interesting hierarchy, and it reminded me of a paper that influenced two articles that influenced me really greatly in during grad school by Michael Polanyi, the great physical chemist, one called Life Transcending Physics and Chemistry and another called Life's Irreducible Structure. And he had this same picture of reality. He took it all the way up to consciousness, which I know Saleem wants to discuss. But he pointed out that the lower level laws apply most broadly, but they also don't explain the origin of the higher level regularities or structures that arise, because there's a vast ensemble of possible ways of arranging matter that are consistent with the lower laws that don't necessarily result in a cell or a trilobite or a rocket ship. And an example I used in my PhD thesis was just, if we take Newton's simple law of gravity, classical law of gravity, it's equally consistent with a rocket ship flying to the moon and an apple falling to the earth. So the law is consistent with both those conditions, but that also means it's not the difference that makes a difference. So what is it that explains how rocket ships fly and why apples fall? Well, that has to do with the particular configuration of matter that's involved in each case, how we put together the metals and the engines to make the rocket ships fly. And so it's the origin of those configurations that laws don't explain. In fact, I came to the view that laws themselves are descriptive, but not explanatory. That oftentimes we, in physics, fall into this kind of fallacy of reifying the laws as if they're things out in nature, when in fact there are descriptions of how nature normally operates. And at the most fundamental level, at the level of the four fundamental forces of gravitation, electromagnetism, the strong and weak nuclear forces, for example, we have these recurring phenomena that we can describe with exquisite precision mathematically, but we don't know what causes the phenomena. Now, Newton first encountered this with gravitation, with this problem of action at a distance, and the problem's never really gone away in physics. So some physicists fall into the way of talking about laws as if they're causes of the phenomenon they describe, when in fact at the most fundamental level, I think they're ultimately mysterious from a materialistic point of view. We don't know what causes those laws. And there I think that a theistic view has something to offer in suggesting that the descriptions are real. The descriptions map to real processes in nature. We're not strictly instrumentalists like David Hume saying that there aren't any laws of nature. There are laws, but the laws reflect some underlying causal principle that I would attribute that to the constant action. What we call laws of nature are a mode of divine action. It's God's way of holding the universe together. And I think that theistic view of what laws of nature are has a great deal to commend it in this philosophical discussion, where there's these three possibilities. Laws aren't really real. That was the Hume's view. They're just habits of the mind. Or laws cause things, which is actually hard to justify when you look at it carefully because they're merely descriptions. A third view is that they are descriptions, but they reflect an underlying causal principle, which is the sustaining power of the creator, which the medievals used to call the potentia ordinata, the ordinary power that is expressed in these regularities.
Yes. I don't know whether that's equivalent to what Hawking said about what breathes fire into the equations and so on. There's this sense of, I mean, Saleem, I don't know if this stuff keeps you up at night at all, but I mean, do you kind of wonder, well, why is the most fundamental sort of order there in the first place? Why is there this, incredible way of describing the way in which the universe works through the language of mathematics, and why is it, and how has this order come to be in the first place?
Yeah, I mean, there is always going to be that sense of mystery. I think we need to recognize that there are certain unknowables, just in terms of our empirical ability to do any kind of research on them. And so that mystery and awe is going to be there. But that mystery and awe does not necessarily validate the explanation from a theist perspective either. And that's the tricky bit, because then, you can get into a situation where you get a kind of regimentation around what you can do ultimately. So one example with reference to these kinds of issues is, the anthropic principle we talk about in ways of explanation of like, this is the way we are and we are observing and that's constraining us. There is, the notion also of the way in which we want to have causality because our minds and the way in which we evolved as a species makes us think of causality as being important. But as you know, Steve was well aware of like Bertrand Russell and others who have questioned even that aspect of kind of causal thinking and whether that's the approach. And in fact, in his book, Steve has also given the example of the sort of Islamic syllogism of kalam and how Kant critiqued that also in terms of, because one of the premises of that was that the universe had a beginning and therefore it had a cause, but that premise itself can be questioned, as Roger Penrose has done with his kind of reverse cyclical cosmology approach, that there was never a beginning or an end. So you can get into those kinds of dynamics, so from my perspective, it's great to have that debate, but I think, again, as a planner, I don't often find that as being very useful in terms of the sustainability questions, which is what I'm geared towards in the long run. But at the same time, in some cases, it can be helpful if we can have a theist view which can help to maintain a certain discipline and taxis around human behavior in a constructive way. That's where I would, that's why I agree with Churchill and others in those kind of constructive way. The problem is a lot of the theist perspectives are exclusionary. And so they lead to a behavior which is actually not very constructive. And that becomes the bigger challenge then. Because the deist perspective takes you towards a theist perspective. And that theist perspective, in certain cases, can be benign, but in other cases can be malevolent. And so as long as we can have a benign approach to it, whether that means, having a more inclusive approach, or whether it means having a pluralistic approach in certain areas, then I'm okay with it. So that's how I approach it in a very instrumental way.
Yes, it's a pragmatic approach in many ways. Stephen, do you want to respond to anything that Saleem's had to say there?
Well, certainly, I think there's a point of really significant common ground here that's worth exploring, and that is that anyone who does planning, especially on the scale that Saleem is involved in, is aware of the importance of agency, that we don't want to simply allow ourselves to be tossed to and fro by whatever forces are at work in our environment or at the level of physics and chemistry, that acceding to a strictly deterministic view of reality that writes out of reality the importance of agency or consciousness or our choice means essentially leads to a kind of fatalism where we can't protect the environment, we can't create the conditions for a thriving economy, for human flourishing generally. And I think one of the things that's come out of the late 19th century and right up in philosophy of science into the 50s and 60s is we've had this kind of deterministic, positivist philosophy of science. And I think people on various sides of these different issues that we're talking about are becoming somewhat disaffected with that. And one evidence of that was the little book that the atheist agnostic philosopher Thomas Nagel wrote in 2012, Mind and Cosmos. And his point was that mind is a part of the cosmos. Agency is a part of the cosmos. And I think a lot of our work on intelligent design has been trying to open people's mind to the possibility that agency can function as a legitimate explanation. And therefore, agency is also an ontological reality. It's part of the world in which we live. And if we have such a narrow view of nature that we want to explain everything deterministically by reference to underlying physics and chemistry, and that there's nothing else except things that are going on at that level, ultimately, then I think we get a very impoverished view of reality, which makes it impossible to pursue the kind of project that Saleem is pursuing. And I think so whether you believe that there's an ultimate agency behind the universe, as I do, or whether you think that human agency is important, I think this deterministic view that we've inherited from some of the kind of rigid physics and philosophy of the 19th century, I think is something that is properly starting to wane in its influence. And I think that's a good thing. I suspect Saleem would agree on that. Yeah,
absolutely. I think that's common ground. But I should note that the deterministic view, unfortunately, also finds its way in certain theologies. And in terms of people who feel that, oh, this is written in our destiny and God willed it this way. So I don't think that is true in all theological traditions, but it does happen in certain ways, and then people end up becoming complacent. I mean, that's how asceticism happens, right? Because people then just withdraw from the world, and that you find in almost all faith traditions, whether it's Buddhism, Islam, or Christianity. So there is a kind of a internal debate, I guess, within various theologies around that. But absolutely, I think we can find common ground that determinism, whether it's coming from the scientists or from the theists, is problematic.
Well, we'll return to this and this question of consciousness, I think, in the final segment of our show, because I want to talk about the fact that it is, the remarkable fact that this order at the beginning of it all results in this sort of almost directionality towards consciousness and us being able to have these kinds of conversations about our place in an ordered universe. So we'll continue the conversation after a short break. My guests today talking about order in nature and the cosmos are Dr. Stephen Meyer and Professor Saleem Ali. For more conversations between Christians and skeptics, subscribe to the Unbelievable podcast. And for more updates and bonus content, sign up to the Unbelievable newsletter. Welcome back. We've been talking about where order in nature and the cosmos comes from. It's part of the subject matter in Professor Saleem Ali's new book, Earthly Order, how natural laws define human life, I should say. Now, if you want more from Saleem, SaleemAli.net is a good place to go. There's a link with today's show. For Stephen Meyer, returnofthegodhypothesis.com for his most recent book. And as I said, we've only scratched the surface of your book, Saleem. Your own book, Steve, is a magnum opus as well. If people want to dig into that, this is something I haven't quite got around to asking you on the show today, Saleem. But you've obviously spoken a little bit about some of the positives and negatives of religion. Do you have any sort of religious outlook yourself? We've only really heard about your scientific and planning sort of credentials at this point.
Yeah, I try to differentiate between literal and allegorical approaches to learning and understanding reality, and both are important. In fact, actually, in Islamic tradition, in the Quran, it's very clearly stated that there are many things which are real and many which are allegorical. The Quran itself states that about the way in which Muslims should approach learning. And for me, I find literalist theistic approaches very problematic. And I think literalism has caused a lot of problems in all religious traditions. I'm fine with allegorical cultural adherence to particular religious approaches, which are willing to embrace certain fundamental tenets of pluralism. And certainly in Islamic tradition, in the Abrahamic religions more generally, it's more tricky because many of the theologies have been very literalistic in terms of their approaches. They have tried to change, but it's always a tension. And certainly in Islam, there is much greater inertia. So for me, I see myself as a cultural Muslim in certain ways, but I do not see myself as a literalist in terms of adhering to specific theological edicts as they're perceived by the mainstream.
Does the question of whether there is ultimately a divine mind, consciousness, whatever you want to call it, behind the universe and nature, do you have an opinion on that, or are you essentially agnostic on that question?
No, I'm agnostic on that question. I think that it's an area which needs to be further debated. I'm not dismissive of possibilities that there may be, whether it's the simulation approach or whether it's other aspects of that. And I don't think anyone should have the hubris to dismiss it. I think the reason why some of the atheists get so militant about it is because have this kind of slippery slope concern that they feel eventually if you
Yeah.
just allow an inch, people will take a mile. And I don't believe in slippery slope arguments. I think we as human beings have the ability to navigate slippery slopes pretty well if we can. And so that's why I try to be more nuanced about approaching it, and with some humility.
And you've been very generous in the way you've conducted this conversation. I know there are some people in your position who, might have reservations even about talking with someone like Stephen, because he does obviously, broach this subject, of religion and faith, obviously in some of the conclusions of his work. But Steve, I mean, it sounds, it sounds like you could get on well with Saleem here.
Well, I'm a big fan of pluralism. It's a civic virtue that we need to cultivate. In our country, in the United States, pluralism was specifically advocated by James Madison, who regarded it as a Christian virtue, as he was tutored by the great Witherspoon at the College of New Jersey, the Reverend Witherspoon, a Scottish Presbyterian who thought that we couldn't conduct civic affairs if we didn't express and have tolerance for people of differing fundamental faith convictions. So I think that's a really critical thing. I think we need a lot more intellectual pluralism in the academy and even in science. We've had trouble raising the issues that we've been discussing today because there's a restrictive and very literally applied methodological criterion that seems that many scientists regard as absolutely normative, and that's the idea of methodological naturalism. That if you're going to be a scientist, you can't consider agency as a cause. You have to limit yourself to strictly materialistic explanations for everything, including human behavior, the origin of life, and the origin of the universe. 3 areas or subjects whereby an explanation by reference to agency might be warranted by the evidence, maybe not, but it certainly is something that we should look at. I mean, if we're talking about what explains the origin of the information that's necessary to build life, it might be the case that strictly materialistic or strictly chemical processes alone can account for that, but it's logically possible that it might not be, that we might need an agency, that agency might have been the cause, and it might be detectable in some ways. So one of the things we've been arguing for is opening up the conversation. There's nothing to be afraid of. And the restrictive view of science we've had from the late 19th century was not the view of science that was that characterized the work of the early founders of modern science. When I was working on Newton in my master's year in Cambridge, and my supervisor directed me to the Principia and to the General Scholium, the epilogue. There in the end, Newton made this beautiful design argument. This most beautiful system of sun, comets, and planets could only proceed from the counsel and dominion of an intelligent and powerful being, right there in one of the greatest works of physics ever written. And you found similar emphasis in people like Maxwell and others. So I think this tradition of detecting or inferring to design as part of or an extension of scientific reasoning has a deep intellectual tradition in the West, particularly in Britain, and it's nothing to be afraid of. We might be wrong, but let's air it out. And that's the kind of intellectual pluralism that I think is really needed. And it will make the discussion so much more interesting.
Where we kind of end up, in the sense that at the mystical end almost of this is with the phenomenon of consciousness. And from what we were saying just off camera and off mic earlier, Saleem, this is one area where you think there might be a sort of a sense in which we're pushing towards a more kind of metaphysical explanation of order and what it amounts to. What's your thoughts on that? Because in a sense, I always find it just extraordinary that we can even have these conversations if we do live genuinely in a world in which everything is based on self-organizing principles. The directionality of that went from inorganic, chemistry to us having this conversation now. It's an extraordinary sort of direction in which nature has gone. Why does it go in this direction? These are the questions that I kind of find interesting. And for me, I suppose, wearing my, theistic biases on my sleeve now, it feels like a theistic story, a story about purpose and a teleology, something, that ends up in consciousness and us having these self-reflective questions makes sense of that. It's harder for me to think that just comes from brute, laws, if you like, that it's just what happens when, laws are set in motion at one end of the universe and now we pop out at the other end, if that makes sense. So what's your feeling on that kind of idea that we are where we are now and talking about this?
Yes, no, I think this is an area where the most interesting kind of commonalities might emerge between religion and science. And I go back to the concept of synchronicity, which is noted in the book also as one that might be interesting to consider in this regard. It was a term coined by Carl Jung supposedly in his conversations with Einstein, where he's trying to understand sort of coincidences that happen in terms of processes and how we might even think about not just consciousness at the level of the individual, but a kind of global consciousness in terms of human societies. And this is something that actually, even from a reductionist point of view, has been studied. There's been, I briefly mentioned there was this group at Princeton, it's called the Princeton Anomalous Engineering Research Group, PEER. And, for 30 years or so, they've been doing this research around, these different kinds of patterns that are found in terms of energy flows, because some of it is, consciousness is around energy flows and getting coherence from energy where we cannot get a reductionist explanation for it, even though, people like Daniel Dennett, whom in my undergraduate days at Tufts University, he was like the leading light in my undergraduate. So I have encountered his work too, but, it's very Darwinian, of course, in his approach. But I think there is more than meets the eye in there, and much more that we should look at. And this kind of the global consciousness project that has come about from that Princeton group, it deserves a careful analysis from mainstream scientists to see what we may find. I mean, there is this ties in with my interest in planetary sustainability also, and people have talked about the linkages of this with planetary systems more generally. And so, yes, absolutely. I think that's an area which is ripe for some convergence of epistemologies.
Do you agree with that, Stephen?
Yeah, I'd like to piggyback off of that. I mentioned this philosopher of science, Michael Polanyi, before. He was also a contemporary of Einstein and had a lot of conversations with him. And he, in this article he wrote for Science in 1968, Life's Irreducible Structure, he explained that the laws at the lowest level are consistent with, but do not determine the constraints that establish laws at a yet higher level. So the laws of physics are consistent with, but do not determine the laws of chemistry. The laws of chemistry are consistent with, but do not determine how electricity flows in a circuit, and on up the hierarchy. And at the top of the hierarchy, he actually placed consciousness, and he defined consciousness or mind operationally by reference to what we know it can do, which is to impose constraints on natural regularities to achieve a particular outcome. So if I'm an engineer, I am aware of the laws of combustion, but just throwing gasoline on top of my car won't get me anything. I got to arrange the parts into an engine and then put the gasoline in the right place. And so my mind as an engineer has imposed constraints on the vast ensemble of possible ways there are of arranging matter, and I've constrained it to form a machine that can accomplish a function. And so the lower level laws of physics are at work, but they don't explain the engine without reference to the engineer. And so he defined mind operationally as that entity in the universe which can constrain possibility states to achieve desirable outcomes, a teleological sense of an end-directed process. And I think there's a philosopher of mine that I like, J.P. Moreland, who says that we know the reality of consciousness better than anything else we know. Everything we know about the external world is mediated through our senses and interpreted through certain assumptions that our minds bring to interpret that sense data. But we know we have conscious awareness because of we have consciousness because of direct introspective awareness. And so I'm inclined to think that that a view like Polanyi's is extremely credible. We can define what consciousness does operationally, but we also know we have it because of direct introspective experience. And so again, I think the importance of agency to our view of reality is really crucial. It needs to be restored. I think we lost that in the 19th century. There's been a lot of reductive work. I mean, Dennett is a great example of somebody who's a very rigorous philosopher, but in the end, he came to a very reductive view of mind. And I don't think it comports with our actual experience, which has to be the final test of the validity of a thesis.
You're nodding in agreement with that, Saleem. Do you think that, I suppose, in my experience, having had the privilege of conducting conversations like this, and also with other noted thinkers, Roger Penrose a couple of years ago in a conversation with William Lane Craig, I was struck in that particular conversation, you know, one of the world's best known physicists, Nobel Prize winner, the way in which he was so, you know, very distinct from his other naturalistic peers, people like Dennett and others, because he refused to be sort of, you know, labelled a naturalist. He was very clear that he thinks there is more than just the natural world. He thinks there is a realm of consciousness. That he thinks there is a realm of mathematics that exist completely independently of each other, and yet overlap in these extraordinary ways in which allow us to do science, allow us to explore the universe, and so on. And so it feels like, I don't know, there might be a bit of a renaissance going on in the direction of people being open to, you know, things other than just a kind of hard reductionistic kind of approach to the natural world. I don't know if that's your experience at the moment, Saleem.
I think there is a greater willingness to engage because there are a lot of these dead ends that theoretical physics is coming across. We do not have yet a unified theory. People are struggling with string theory. They're struggling with some of the investments that have been made at CERN and getting useful output. So, you know, you have people like Sabina Hassenfelder and others who have criticized contemporary physics, but she has still done it from more of an atheistic perspective. So I think you do have that, but there's still that slippery slope fear. And so you are seeing a willingness to engage, but I think you will still have quite a long way to go before you get some kind of convergence of at least, again, as a planner, looking at it functionally, like where can we find convergence so that we can all work together, whether we are more naturalistic in our approach or more deistic or theistic, to actually solve the problems of the world, which is what I'm working on in terms of my role with the United Nations. I serve on 2 UN panels, and we have lots of basic science problems to deal with in terms of figuring out what's happening to the ozone layer and all. And we have lots of social science problems to deal with in terms of poverty alleviation and traffic and, accidents and so on. So I think that's what we should focus on. And I've seen that from, some of the theists. I mean, we've seen that from the Pope in terms of his recent efforts at trying to outreach to scientists and so on, dealing with environmental system science especially. So I think that's where we should try to focus our energies. And it comes down to that level of granularity, which Steve was talking about as well, that sometimes it's okay if we are operating at different scales and have different notions of order at those scales. But as long as we can functionally make things work for whatever audience is more receptive to different approaches, right? That's how I see it.
Do you agree with that kind of pragmatism?
Well, yes, of course.
Steve,
and I commend
sense?
Saleem for his attempts to help the planet. I mean, but the philosopher in me couldn't let pass your mention of Penrose and mathematics, because I think one of the areas where there's a very decided movement against philosophical or scientific materialism is not only in the area of mathematics, but in understanding how mathematics applies to the physical world. Penrose is, of course, a mathematical Platonist. I, in my most recent book, wrote about some theories of cosmology known as quantum cosmology. And these were, in fact, probably the go-to atheistic explanations to try to circumvent the Kalam argument that about the beginning of the universe that Saleem mentioned a minute ago. But one of the curious things about these theories of quantum cosmology is they attempt to explain the origin of the universe as a result of a pre-existing set of laws of quantum physics that are essentially mathematical in character before there is a physical universe. And one of the proponents of this, Alexander Vilenkin, actually has reflected deeply on this kind of paradoxical result. And he said, look, before there was matter, space, time, and energy, what tablet could these laws have been written on? If they are strictly mathematical and therefore they're conceptual, and then he says, but mathematics exists in the realm of the mind. Are we therefore saying that before there was a universe, that a mind predated the physical universe? And there's an interesting discussion in mathematics about the unreasonable applicability of mathematics to the physical world. We've been talking about order, but we haven't talked that much about the mathematical facets of that. And this goes back to an article that was written by Eugene Wigner, the great Hungarian physicist in, I think, 1960. And that argument's been resuscitated recently in an article at the journal Inference by Sergiu Kleinerman, the great Princeton physicist, who shows that you can deduce all the most fundamental categories of mathematics from very basic axioms in arithmetic, get all the way to differential equations and complex analysis and partial differential equations from these arithmetic rules. So you have this whole apparatus of mathematics that can be deduced solely by thinking internally, but then we find that even esoteric forms of mathematics, like complex analysis, the mathematics of imaginary numbers, ends up applying to the physical world in ways that we never imagined. And this is a great mystery. Why does the reason within, as Sir John Polkinghorne, the great Cambridge physicist, put it, match the reason that's embedded within the universe? The reason in our own heads, why does it so beautifully match? And I think that gets back to that whole question of intelligibility that we were talking about at the beginning, that the order that Saleem has so beautifully characterized very often can be described with very precise mathematics, and very often that mathematics pre-existed its application and was simply deduced from logical first principles and a few simple axioms. It's a fascinating aspect of this discussion.
Yeah, no, that's great to know. Actually, Vilenkin was my intro physics professor at
you're
Tufts. As a spring chicken, I was a 19-year-old taking intro physics.
Well, he's not only a great physicist, but he's very deep philosophically. And in this quote, paraphrase that I cite, it's from the very last page of his book, Many Worlds in One. And it's exactly what Hawking meant too, because Hawking was talking about his quantum cosmological model when he said, what puts fire or breathes fire into the equations that gives them a universe to describe? It's one thing to understand the patterns, the order in nature by reference to mathematics. It's quite another to say that the mathematics somehow causes the universe to come into existence or those patterns to exist. And that's been a deep conundrum, I think, for a lot of materialists, scientific materialists.
Well, look, it's been fascinating to both think of the pragmatic issues
and the practical. As sorry, Saleem, to divert.
The practical aspect. Yeah. But I think we've met somewhere in the middle as we think about the big metaphysical issues and the practical issues of order in the universe and nature and in society. But there's so much more we could have dug into, and we didn't get time today. But it's been a wonderful conversation. I've learned a lot, and I just really enjoyed being in the middle of two wonderful thinkers today. So Saleem and Stephen, thank you very much for joining me.
Thank you, Justin.
So for more conversations between Christians and skeptics, subscribe to the Unbelievable podcast. And for more updates and bonus content, sign up to the Unbelievable newsletter.